Hello, hello. Today we are now proving similarity through transformations. So we've done this before with congruence. So remember from before, two figures are congruent if one figure can be mapped onto the other using a series of only rigid transformations. So those are those translations, reflections, and rotations. So that's what we've already done. The new part is we are now looking at similar figures. So two figures are similar if one figure can be mapped onto the other using a series of rigid transformations plus a dilation. So we're still going to use translations, reflections, and rotations, but we also have to have a dilation thrown in. So just a quick reminder of these three translations. Remember, xy goes to this, or we could write it as a vector. Rotations, you need to include the degree and what point you're rotating about. You also should include whether it's clockwise or counterclockwise. Reflections, you just have to say which line you're reflecting across. Remember, we had things like y equals x equals 2, the y-axis, the x-axis. Okay, so we'll apply those first. And you want to get the two shapes to line up so that one of the vertices is in common, and then you can expand or condense. So then we apply the dilation. The dilation, you have to include two things. You have to say what your scale factor is and what point you are dilating about. Okay. So for example 1, first thing I'm going to do is get G to line up with G prime, but I want the shape facing the same direction. So the first thing I did was rotate it 180 degrees about point A. So all I did was connect G to G prime, and then I found the point right in the middle. And that way when I rotate it, it lines up perfectly. And this shape is twice as big as the other shape. So to get from G to G prime, we're going to dilate with a scale factor of 1/2, and we're dilating from point G prime. All right, so number 2, I'm taking this big shape and turning it so that it lands on the little shape. So that means I'm rotating it 90 degrees counterclockwise about point A. And again, this shape ends up being twice as big as the new shape. So I'm going to dilate with a scale factor of 1/2 about point A double prime. Because you notice these were labeled with double prime instead of single prime. All right, so these ones we want to practice 3 moves. Some of them can be done with less than 3, but we're practicing, the fact that it doesn't always take 2 moves. And a lot of these have more than one possible way to do it. So this is just the way I saw it and chose to do it. So first thing I did is I'm going to take the small shape and get it to line up with the big shape. So I'm going to move it over 4 spaces. So I'm going to apply the vector 4, 0. I then want it to go the same direction, so I want it to flip and point upward, so I'm going to reflect across the x-axis. And then the new shape is twice as big as the old shape, so I'm going to dilate with a scale factor of 2 about point D. All right, and example 4. Again, we're going to use 3 rules. So first thing I'm going to do is get point C to line up with point X. So I'm going to translate it 1, -2. I then want this to turn so that the sides line up together. So I'm going to rotate it 90 degrees clockwise about X. And then the pre-image is half the size of the image, so I'm going to dilate with a scale factor of 2 about point X. And that's all the notes we have for today. So happy Friday and have a fantastic weekend.